Okay, so biology test is worth 100 points and has 36 questions. A says multiple choice questions are worth 2 points each and essay questions are worth 6 points each. How many questions of each type are on the test? Now somebody asked me last period, I don't know how to set it up. I don't even know when I have to use a system. So the key to this is that I see two essential things. I have two different values. I have the value of the test itself. So let me underline that. The test itself is worth 100 points. And then I also have the total number of questions. Those two elements are separate. So that is a good indication that I will be creating a system to solve. Does that make sense? So, great. So, let's say the very first thing that you want to do is indicate what your variables are. So I'm going to say number of multiple choice questions. And E, I'm going to say the number of essay questions. Right? So, how can I formulate an equation using those variables and the 36 questions first? Yes?
X plus y equals 36.
Yeah, or m plus e equals 36. Perfect. So I'm going to have m plus e equals 36. M plus e equals 36. And then I have to make another equation that incorporates the specific point values of the multiple choice questions and the essay questions. What will that look like? Someone else? Yes. Close, very close. Yes.
2m plus 6e equals 100.
100, right, because you have to utilize the point value of the test itself. So, 2m plus 6e equals 100. Now I can use substitution. Move this up. All right, so I have to just isolate a variable. It doesn't matter which one I'm going to isolate. I'm going to go ahead and isolate the m since that one comes first here. Isolate that m, and then I'm going to put parentheses here so I remember to plug it in my second equation, the one I'm not isolating for. So in order to isolate for m here, what do I do with the e? Subtract it. Perfect. So I end up with m equals 36 minus e. I'm going to take that and I'm going to substitute it into my second linear equation. Right over here. Okay? So, let me give myself some room. Do you have any questions so far? No. Okay, let me plug in my computer. If you haven't finished this problem, go ahead and finish it up. Otherwise, you can wait and let me finish it. But you have to be able to do this on your own. So if this is still confusing to you after the spell work problem, make sure to come in and ask for some help. So now we're just at the point where we're substituting. So I'm going to take 2. I'm going to multiply that by 36 minus e. And then I'm going to say plus 6e equals 100. When I do that, and I use my distributive property, what do I get? You can just say it.
216 minus 600.
Not 216. Let's just do our distributive property here. 72, right.
Oh, 2.
72
I did that.
minus 2e plus 6e equals 100. Perfect. Then we combine our like terms, we get 4e. Somebody said it. Great. 72 plus 4e equals 100. And then, of course, we subtract 72 from both sides. And what do we get? Perfect. 4e equals 28. So how many essay questions are there? 7. There are 7 essay questions, which means how many multiple choice questions must there be? 29. Correct. So you don't have to list that as an ordered pair based on the context of the problem. So you can just say there are 7 essay questions and 29 multiple choice. Okay? Do you have any specific questions on this? Okay, now let's look at part B. Part B says your friend says that it is possible for the multiple choice questions to be worth 4 points each. Is your friend correct? Explain. Why would they not be correct? Yes.
Because then the test wouldn't have 30, or it wouldn't be equal to 120. It would be like 129.
Well, it would be over 100, right? Now, notice the problem itself. It doesn't say let's reduce the number of essay questions so that we still have 100 points. It says given these particular 7 essay questions and 29 multiple choice questions, can they be worth 4 points? Well, no, because then we'll get over 100, right? If you look at this and you say to yourself, well, yeah, it can be possible if I reduce the number of essay questions. Yeah, but we're not going to do that. We don't have that stipulation. It just says, is it possible for the multiple choice to be worth 4 points? So no. No. It would be over 100 points. All right. That is an item under your table of contents for your assignment packet. So make sure that you have all those questions answered and that you label it bell work and then the date 12/1. All right, take out your homework. 5-2 homework. We're going to be grading that. All right. Start your notes. Guys, slow it down, please. All right, we're going to take a look at solving systems by elimination now. We looked at substitution last class. So our central question, how can you use elimination to solve a system of linear equations? You've seen this before, hopefully in middle school. As the name implies, you are eliminating one variable because we don't want to work with 2 unknowns. So like substitution, it's very systematic, it's very step-by-step. So it says multiply if necessary one or both equations by a constant. A constant is just a number, negative or positive, so at least one pair of like terms has the same or opposite coefficients. And you want to add or subtract the equations to eliminate one of the variables, solve the resulting equation, and then substitute the value from step 3 into one of the original equations and solve for the other variable. Okay, real quick, what I mean by that, let's say, just as a refresher, let's say that you have the following system of equations, okay? And you want to eliminate the x's. What would which equation would I use, the top or the bottom? And what constant would I multiply by to eliminate the x's?
Multiply the top by 2.
Multiply the top by -2, right. So, in order to perform the elimination, you have to multiply both sides by -2. You're simply changing the form of the equation. So I'm going to write this in a different color in purple here. So when you multiply by -2, you're distributing that -2 to the entire equation. So what do I end up with?
Negative 4x minus 6y equals -12.
-4x minus 6y equals -12. Perfect. And then you can just add straight across, eliminate your y's, and then solve for, or eliminate your x's, then solve for y, plug your y back into one of the original equations, and solve for the value of x. Okay, here we go. We're going to solve the system by elimination here. So, in the easiest case, we won't have to multiply by a constant at all. We can simply just add our two equations together and one will eliminate. What variable will eliminate when we perform addition?
Y.
The y. Right, so that's exactly what I'm going to do. Draw a line here, and I'm going to perform the addition. I get 6x equals 0. I solve for x. Use my division property of equality. And I get x equals 0. Now, you need to plug the value of x back into one of your original equations. It does not matter which one, as long as it's a non-manipulated equation. So I'm going to take this and I'm going to plug it back into the first one. So I have 3 times 0 plus 2y equals 4. 2y equals 4. What's the value of y? 2. Right. So what's the solution to my system? 0, 2 in parentheses. Remember, it is always a point unless you're dealing with parallel lines or the same line. Then we have special solutions. All right. That's the easiest case. Do you have any questions on that? All right. All right. So let's take a look at this here, this system. Okay, so I have to manipulate one of my equations here because what I notice is that I cannot just add straight away and eliminate one of my variables, correct? So it doesn't matter which one I start with or which one I choose. Okay, I can choose the first equation or the second equation. If I multiply the first equation by 2, I will get negative 20x plus 6x equals 2, and the 6's will cancel out. Or I can multiply the second equation by what? Negative 2. Right, and then I get positive 10x, and those x's will cancel out. It does not matter which one you choose. Okay, so let's go ahead and go with the top one. So I'm going to multiply both sides of that equation by 2. Multiply by 2 here on this side. Multiply by 2 here. So when I do that, I get negative 20x plus 6y equals 2. And then I'm just going to rewrite the original bottom equation as negative 5x minus 6y equals 23. I'm going to add, and then I get negative 25x equals 25. do my division property of equality, negative 25 divided by negative 25. I get x equals negative 1. Now, what do I do to find the value of y?
Plug it in.
Plug it in. Now, you cannot plug it into, do not plug it into one of your manipulated equations. So don't plug it into this one. You must plug it into one of your original ones. So go ahead and plug it into the first one and tell me what you get. Into one of them. One of the original equations. When you plug in negative 1 to the first equation, you get positive 10 plus 3y equals 1. Then you subtract 10 on both sides, you get 3y equals 9. Three y equals negative 9, sorry about that. So y equals negative 3. So what's the solution to my system?
Negative 1, negative 3.
Negative 1, negative 3. Perfect. All right. Okay, so this word problem says a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. What is the cost of each type of van? Again, to determine whether or not you have to use a system or set up a system, you have to look at your problem and examine that you have 2 different variables here. You have the cost for a small van and the cost for a large van. Those are 2 separate variables, so we're going to set up a system to solve for each of those variables. Does that make sense? Okay, so very first thing we want to label. So here's what I'm going to do. I'm going to use L to represent the cost of a large van. I'm just going to put a little $sign cost of large van. I'm going to use S for the cost of the small van. All right. So, how will I set up the equation for location A? Pay attention up here. How will I set up the equation for location A? Yeah, 5, let's do L and S, right? 5L plus 2S equals what? Right. 5L plus 2S equals $235,000. Now, let's set up our equation for location B. 2L plus 3S equals 160,000. All right. What is the problem here? What makes this system of equations more difficult than the ones that we've seen? Yeah, you have to manipulate both of these equations in order to get rid of one of the variables, right? So you can approach this in a number of ways. The way I'm going to show you is just one example of the ways that you can approach this problem. So what I'm going to do is I'm going to multiply the top equation by negative 3 on both sides. And then I'm going to multiply the bottom equation by 2 on both sides. All right? So, when I change the form of those equations, this is what I get. Negative 15L minus 6S equals negative 705,000. And then 4L plus 6S equals 320,000. What variable can I eliminate? S. I'm going to add straight across, and I'm going to eliminate my S's. Well, when I do that, I get negative 11L equals negative 385,000. Right, you're going to divide by negative 11. When you divide by negative 11, you end up with the cost for your large van, which is going to be $35,000. Now, to find the cost of the small van, what do? Plug it back into one of the original equations. So either the green here or the red here. It doesn't matter which one, and when you do that, you get the cost for the small van at $30,000. Do you have any questions about that? Keep in mind that you might not always, it's not always as simple as just adding straight across. You may have to manipulate one or both equations. Okay. This is your updated table of contents. So you should have all of these items on your table of contents 1 through 7 with the dates.